Hello everyone, welcome to my channel. So in the previous video we did the 2D analysis of IRIS dataset wherein we took sepal length and sepal width as our features. In this video we shall look at the 3D plots of IRIS dataset. Okay, so for that we need to go to this link. Okay, so over here you can see on the first line it is importing a package called plotly. Okay, then after that it is getting the iris data set, then it is plotting the 3D plot with x axis being the sepal length, y axis being the sepal width, and z axis being the petal width, and the color changes according to species, which is variety in case of our dataset, the dataset present on Kaggle. Okay, then after that you can see we get a plot like this. Okay, so now over here it is highly functional. You can rotate it and see it in different angles. You can zoom out, zoom in. Okay, so over here as well, let's perform the analysis. So what I'm gonna do is I'm gonna move to my notebook, but before that let me get it to a certain orientation so that we can see how things are. Yes, okay, so this does. Okay, so in this 3D graph we can see that the blue points are setosa. Okay, the green points are virginica and the red points are versicolor. Okay, and over here you can see there is a overlap between virginica and versicolor. So our first conclusion is gonna be similar to what we had in 2D analysis, that virginica and versicolor have overlap. Okay, and over here you can see that setosa is clearly separated from the other two species. So if I were to create a plane like this, then I would be able to separate setosa completely from the other two species. Okay, so now over here you can see that as setosa is only on this side of the plane, so if we were to create a model, then that would be 100% accurate. Okay, if we create a model to separate setosa from others. Okay, so if we were to create a model to separate setosa from others, the model is gonna be 100% accurate. Okay, but in the case of 2D analysis we saw that it was not 100% accurate, but it was very close to 100% accurate, and the reason being that we had some plots on this side of the graph. Okay, so now you see that if we move from 2D to 3D, we can achieve 100% accuracy in separating setosa from others. Okay, so moving from 2D to 3D means that over here instead of two features, over here if we use three features, the first is petal width, second is sepal length, and the third is sepal width. Okay, so if we use three features we can achieve 100% accuracy. Okay, so this was the 3D analysis. In the next video we shall see pair plots. Okay, so see you in the next video. Thank you.